Hello everyone, welcome back to this video series on clinical SAS programming. In this video, we will see how to easily remember the 6 rules of ADaM BDS dataset. So there are certain rules which will guide us on when to add an analysis information as a derived row or a derived variable. So there are 6 rules as per ADaM IG which govern that creation of columns or rows. So we'll try to remember the rules by using this simple keywords listed on the left hand side. For rule 1, we'll have to remember the change from baseline value. For rule 2, so we will have to remember L10WT, which stands for change from baseline analysis for weight, but the terms in terms of logarithmic values. So we'll see in detail on how we can more easily reconnect this L10WT keyword later, but for rule 2 we can remember L10WT, and then for rule 3 we can remember the keyword minimum post baseline, and for rule 4 we can remember the keyword AUC, and for rule 5 we can remember the keyword BMI, which is body mass index. And for rule 6, we can remember this keyword two baseline definitions. So change from baseline is governed by rule 1. Change from baseline analysis of logarithmic 10 of weight values is governed by rule 2. And addition of a row corresponding to minimum value seen during post baseline is governed by rule 3. And when we need area under the curve, accumulation of values present on different records within a parameter, so we can remember rule 4 with the keyword AUC, and rule 5 with the keyword BMI, which is body mass index, which is derived using height and weight collected for the subjects. And then for rule 6, we'll have to remember the keyword two baseline definitions. So in general, in most of the cases, we will have only one definition of baseline within a data set, but there can be cases wherein more than one definition can exist for a baseline. So in that case, so rule 6 governs on how to structure your ADaM dataset. So we'll now see how to go or understand these rules better by for each individual rule. So here is our rule 1, which says a parameter invariant function of eval and base on the same row that does not involve transformation of base should be added as a new column. So the core variables in your ADaM dataset would be the subject related variables and the parameter related variables and the visit related variables, and your analysis result, which is stored in the variable called eval. So these are the main important variables that will be part of your ADaM BDS dataset. So anything extra would be added as new columns or rows. So what does rule 1 say? So if we need an analysis information which is parameter invariant, which means that variable that the information is not dependent on the parameter that we are going to derive. So the simplest example here is change from baseline. So if we are populating change from baseline on a particular row, so we will populate it as the same across rows. So how do we populate change from baseline? The result on a particular row minus the baseline value of that subject. So for all the parameters, the algorithm is the same. So for change from baseline, we subtract the baseline value for that subject for that parameter with the from the value collected on a particular row. So if we need to add some analysis information which is parameter invariant, which means the algorithm is not dependent on the specific parameter, and if it involves both eval and base. So here if we take the example of change, so it involves both eval and base, and they should be from the same row. When we are calculating change, so we pull the value of eval from the same record and we use the value from base on the same record and then populate change from baseline. If it is a function of eval and base on the same row and that does not involve a transformation of base, so we have baseline variable, we populate this column with the values whichever is becoming baseline, so as per the definition in that study. So if we are employing an algorithm, and if we are using base variable on that, and we should not apply any manipulation on base variable. It should be direct copy, direct value from base should be, we should be able to use the value. So what do we mean by transformation? Let's say in the next example we will see some application of logarithmic function on the base value. So this is called a transformation. So if the actual derivation or algorithm does not involve transformation of the baseline, so rule 1 has to be applied and you will have to add that as a new column. So as from all the 6 rules, this is the only rule which talks about the addition of a new column. So rest all rules talk about the addition of new parameters or new rows, but the only rule that talks about addition of a new column is your rule 1. So in order to remember rule 1, so you'll have to remember the keyword change. So the algorithm for it is result minus baseline. So if you go by the rule 1, it says if an analysis information is parameter invariant and it is a function of your eval and base on the same row, and that does not involve a transformation of base, then it should be added as a new column. So change from baseline column is added to the ADaM BDS dataset as a column based on rule 1. So now we'll move on to rule 2. So the rule 2 says a transformation of eval that does not meet the conditions of rule 1 should be added as a new parameter, and eval should contain the transformed value. Let's say we want the change from baseline for log 10 of weight. We have height collected, we have weight collected here. So, but we want to analyze the change from baseline in terms of log 10 of eval minus log 10 of base. So here if we see, if we have to create a column or rows, so we are applying some transformation on eval, and a transformation of eval that does not meet the conditions of rule 1 should be added as a new parameter, and eval should contain the transformed value. So the overall analysis that we want to do is we want to find the change, but in terms of logarithmic of eval and log 10 of base. So this violates the rule 1 because rule 1 says that we shouldn't transform base. So if we are supposed to create a new column and which is a function of eval and base, so but rule 1 clearly states that we shouldn't transform the base values when we are trying to add it as a column. As we are violating the transformation of base, so what should we do is we should add the resulting things as a new parameter. So what do we do here in this case is, so we have weight values collected, and for each value of weight collected we create an additional row, but on the as a new parameter. So on this new parameter, what do we do is we apply log transformation for your eval and then store it in the eval variable. So you pick the eval from your original weight of screening, for example here, and then apply log10 function on that, and then store the resulting value on the eval variable in L10WT parameter. So a transformation of eval that does not meet the conditions of rule 1 should be added as a new parameter, and the eval should contain the transformed value. So that's what we are trying to do here, log10 of eval. So, so now we have seen the rule 2. So now let us move on to rule 3. So what does rule 3 say? So it says a function of one or more rows within the same parameter for the purpose of creating an analysis time point should be added as a new row within the same parameter. So important thing to remember is this for the purpose of creating an analysis time point. So here when trying to remember the rule 3, we said we will remember it with the keyword minimum post baseline. So let's say we have a table shell wherein we are trying to summarize the information in terms of each visit. Let's say screening, and then we will present the descriptive stats for those things, and followed by this month one visit analysis for all rows. And let's say we have in that same shell, after all the visits are presented, we have this summary for the minimum value seen during post baseline period. So here these are all true analysis time points. So this is a new time point which is conceptual. So this is not collected, but as per the table structure, we want to summarize the minimum post baseline value as an analysis time point. So this is a conceptual time point that we are creating. So whenever we have such kind of analysis requirement, it says a function of one or more rows within the same parameter for the purpose of creating an analysis time point should be added as a new row within the same parameter. Here if we see, we have weight values collected, and within the same parameter we are adding the minimum post baseline. So we would check for all the values for the collected time points, and then we will see what is the minimum. Here as we are saying it as post baseline, so we would consider all the post baseline visits, see what is the minimum, and present that eval value here. But on that record we put the a visit value as minimum post baseline. So it says a function of one or more rows. Is it a function of one row or more row? So if it is minimum, maximum, or the last observed value, so it would be a function of only one row from the observed data, because out of all these rows, only one of those rows would be replicated here. So when will we have the function of more rows? So let's say if we are taking the average of all the post baseline values. So at that time, so the analysis value is a function of more than one row. But for this case of minimum post baseline, it says a function of one row within the same parameter for the purpose of creating an analysis time point should be added as a new row for the same parameter. So when we add something as minimum post baseline as a row, we go it because of the rule 3. So based on rule 3, so we will have to add it as a new row within the same parameter. Now let us move on to the next rule. So which says a function of multiple rows within a parameter should be added as a new parameter. So the only difference between rule 3 and rule 4 is there also it is a function of one or more rows, but there it was for the purpose of creating an analysis time point. So here we do not have that concept of for the purpose of creating an analysis time point in rule 4. So there will be in cases wherein we may want to summarize the information from multiple rows within the same parameter. Let's say this cell count of CD4 is collected at week 0, 1, 2, 3, etc. So here we want to try to get the cumulative CD4 at week 0, cumulative CD4 at week 1, cumulative cell count of CD4 at week 2, and cumulative cell count at week 3. So how does this get derived? For week 0, it would be a copy of this one. But for week 1, we would have to use the two rows of week 0 and week 1 and then populate the resulting eval value. And at week 2, we would have to use the information from week 0, week 1 and week 2 and then populate the result at week 2 for cumulative CD4. And similarly for week 3, we would have to use the information from all the four rows of week 0, 1, 2 and 3 and then populate the resulting value here. So in such cases, so we are being asked to populate a new parameter. So a function of multiple rows within a parameter should be added as a new parameter. So this can be remembered with the keyword area under the curve or some maybe you can also use the keyword cumulative. So for this same example, so here if you see a function at, if you take a look at this one, the last row, a function of multiple rows. So the result value at week 3 for CUM CD4 involves more than one row within the same parameter. So these are all the rows of CD4, but it is a function of more than one row. So as per this rule, a function of multiple rows within a parameter should be added as a new parameter. So for the same reason, so we are adding it as a new parameter and presenting the cumulative eval here on these rows. And now let us move on to the next rule, which says a function of more than one parameter should be added as a new parameter. So rule 4 was talking about a function of more rows, multiple rows within the same parameter. But here it is a function of more than one parameter should be added as a new parameter. So let's say we have height collected and weight collected. So we need to derive BMI, which involves or which can be derived by using the height and weight of the subjects. So if we want to create the analysis value of BMI, so it involves derivation of from two different parameters, a function of more than one parameter. So BMI involves derivation from two different parameters here. So that's why it should be added as a new parameter. For the same reason, so we are creating new rows for BMI by deriving the BMI value by using the weight value and the corresponding height value collected. So in adult studies, so what happens is the height value will be collected only once, because in the expected duration of the study, the subject's height will not change. But in some pediatric studies which goes on for 2 to 3 years or 1 to 2 years also, so the kid's height would change over different time points. So for in such cases, the height would also be measured at different time points. In such cases, so you would have to map the height values at the corresponding time point. But in this example, we only have the height listed once, so with the assumption that so height doesn't change, so it is collected at screening. So we would use the height value collected at screening for all the different weight values collected over different time points and derive the BMI for each time point. So a function of more than one parameter should be added as a new parameter. So BMI is the keyword that we are going to use to remember the rule 5. A function of height and weight. BMI, if you remember. So it is a function of height and weight. So we'll have to add it as a new parameter. And then one other example of rule 5 is, let's say we have a different questionnaires collected. So we have within a questionnaire, let's say we have question numbers 1 to 8. So, and then we want to calculate the overall sum of these scores and create it as a new row. So if we want to analyze the sum of these scores, so if we want to analyze the sum of the scores, so it becomes a function of more than one parameter, because each of these questions will be a separate parameter, and then the value that we want to analyze is a function of more than one parameter. So it should be added as a new parameter. So we may create something as that total and then store the resulting sum in the eval value on that row. And now let us move on to the last rule. So when there is more than one definition of baseline, each additional definition of baseline requires creation of its own set of rows. So in most of the cases, what will happen is, so the last known value before the treatment start would be used as baseline. But there can be some cases we want to analyze the change from two different uh, con values seen during. Here in this example, so the QTCB values, these are some parameters within ECG data. You have a interval called QTC interval in your QTC interval in your ECG time. What do we call it? In your, we get a graph in your ECG, and there they measure an interval between the Q peak and T peak or something, and then you get the value as QTC. So here it is collected in triplicates. So for analysis purposes, what they want to see is the for all the post baseline values. So once the results are collected, so they want to see the in during the screening it is collected in triplicate reading 1, 2 and 3. So out of these three values for at each different post baseline time point, let's say at month 1, what do I want to see is see the change by using the minimum value seen during the screening period, and at the same time and also from the maximum value seen during screening period. So similarly, so what is this saying? So when there is more than one definition of baseline, each additional definition of baseline requires creation of its own set of rows. So here if we see, we have at screening period, we have readings collected in triplicates, out of which let's assume that this reading 1 is the minimum value and reading 2 is the maximum value. So at month 1, I want to see the change from baseline, but with the value coming from the minimum value. But again, at the month 1, I also want to see the change from baseline, but by using the maximum value seen during post baseline. So for that reason, what I'm doing on the second set of rows where I'm indicating the base type as maximum, I am populating my base variable with the value maximum value seen during post screening period, which is your eval. So I have indicated with this with a darker green shade to indicate the maximum baseline, and the lighter shade here a lighter shade of green to indicate the minimum baseline. So on all these rows, the change value indicates that the change is from the minimum value seen during post baseline period, and all these where rows where base type is indicated as maximum, and this base value is basically populated from the value of reading 2, which is the maximum value seen during screening period. And then when I calculate the change, so when I use the eval from here and the base here, which is your maximum value, the change would be from the eval minus maximum change. So when there is more than one definition of baseline, each additional definition of baseline requires creation of its own set of rows, and you would indicate the baseline uh, type in your base type variable. So here I picked the value of minimum because I am populating the baseline on this set of rows with the minimum value seen during screening period. And then on the second set of rows, I am populating the baseline variable by with the value with the maximum value seen during screening period. So I picked the keyword of maximum. And there can be cases where you want to average all the three values and then also create a third baseline type. So once you pull it with the minimum, and once you want the change from the maximum value, and once with the average value. So in that case, so what would happen? We would have all these rows replicated again here, but on this set of rows, so you would populate the base type as average because you would populate your baseline value here with the average value of these three readings and then populate the base column. So that's how you can remember all the 6 rules of ADaM. So let's go back and then try to recollect the keywords that we have used. So rule 1, change from baseline. So a parameter invariant function of eval and base on the same row that does not involve a transformation of base should be added as a new column. So change from baseline is added as a column based on this rule. A transformation of eval that does not meet the conditions of rule 1 should be added as a new parameter, and eval should contain the transformed value. So we have seen that in terms of change from baseline of log 10 of eval and log 10 of baseline weight. So we have created this new parameter called L10WT. And then rule 3, we wanted to remember it with the keyword minimum post baseline. So a function of one or more rows within the same parameter for the purpose of creating an analysis time point should be added as a new row for the same parameter. And then rule 4, we thought we would go with this keyword AUC, which is area under the curve, or we also said that we can remember it with the word cumulative. So wherein we were trying to populate the result as a cumulative value from all the prior time points or up to that time point collected. So a function of multiple rows within a parameter should be added as a new parameter. And rule 5, we wanted to remember it with the keyword BMI. So a function of more than one parameter should be added as a new parameter. BMI derivation involves using your height and weight values. And then the rule 6, so we wanted to remember it with the keyword two baseline definitions. When there is more than one definition of baseline, each additional definition of baseline requires creation of its own set of rows. So this is how you can try to easily remember all 6 rules that govern the creation of new columns or new rows in your ADaM BDS datasets. So let us see how many uh, rules are there which asks us to create new parameter. So here if you see, this is asking for us to create new parameter, and then this is asking us to, rule 4 is asking us to create a new parameter, and rule 5 is asking us to create new parameter. So there are 3 rules which ask us to create new parameters. So what are they? Rule 2, rule 4 and rule 5. And so baseline, multiple definition of baseline, so there is one parameter, and additional of rows within the same parameter, there is one rule, and there is only one rule which asks us to create a new column. One rule is related to your addition of new column. 3 rules are corresponding to your new parameter, and one rule for creation of rows within the same parameter, and one rule for creation or replication of rows for each definition of baseline. So there are 6 rules in total. Thank you for watching and keep learning.